When you look up at the sky at this incredible satellite infrastructure we've built, I mean, hundreds of Earth observation satellites circling the globe, you'd be forgiven for thinking we have a perfect, a real-time grip on the state of our planet. We have the technical capability to monitor almost everything.
And then reality hits.
Yeah.
You look at October 2024, when that catastrophic DNA storm delivered flash floods to the Valencia region. We're talking over 200 lives lost and damages estimated at over 50 billion euros.
50 billion, and that's just the most recent example. I mean, we saw the 2021 floods across Germany and Belgium rack up, 46 billion in damage? These are multi-billion euro disasters happening with just alarming regularity despite this massive technological advantage we supposedly have.
Right. Globally, the economic toll from weather and climate extremes, just between 1980 and 2023, it exceeded 790 billion euros. So what's fascinating here, and really the core paradox, is we have this unparalleled space asset capability, yet we're still just absorbing these catastrophic losses. Why aren't we translating observation into, prevention and resilience at the scale that's actually required?
Okay, let's unpack this. Because that paradox, that gap between what we can see from space and what we actually do on the ground, that is the central focus of our deep dive today. We're pulling directly from the policy brief from the Open Earth Monitor Cyber Infrastructure Project, or OEMC. This is a huge initiative funded by the EU's Horizon Europe program.
And this OEMC report is, it's really an indispensable guide to the future of data-driven governance. Our mission today is to walk you through their findings on 3 critical areas. First, the overwhelming economic rationale for open Earth observation data as a kind of societal safety net. Second, the massive and frankly ridiculous technical bottlenecks, like this problem of wasting petabytes of cloud storage. And then finally, the emergence of GeoAI paired with these critical questions about the digital sovereignty of Europe and how we should ethically align this new intelligence.
So let's start with the money, because the economics here are, they're just incredibly compelling. The OEMC report frames the investment in Earth observation as remarkably low cost compared to the threats it helps mitigate.
Absolutely. If you look at the operating costs for Europe's space infrastructure, so primarily the European Space Agency, which manages the crucial Copernicus Sentinel missions, the cost to European citizens is about 0.06% of GDP.
0.06%.
Exactly. It's a tiny fraction compared to the sheer size of the problem it's supposed to solve.
And that cost is just minor when you stack it up against the cost of floods and droughts alone, which is somewhere between 15 and 26 billion euros every single year. It's basically a mandatory form of global risk insurance.
And that insurance pays out constantly. Here's an insight that really illustrates the return on investment. The brief notes that improvements in hurricane track forecasts, which are entirely enabled by better observation data, have reduced the economic impact by approximately $2 billion per hurricane.
Wait, hold on. $2 billion.
$2 billion.
Per hurricane.
Per hurricane.
Yeah.
That's not just a good return. That means the observation system literally covers the cost of entire agencies and operational budgets multiple times over, just by giving people a few extra days to prepare. Precisely. And the function of this data has broadened so far beyond just crisis management. Copernicus Sentinel data, available under an open data license, which, by the way, the EU pioneered, is now the foundation for governance itself. It underpins key EU environmental policies, everything from the massive common agricultural policy to the critical EU deforestation regulation.
I love that idea of an open license creating that transparency. The system gives you weekly revisits at a high spatial resolution of 10 meters, allowing for global scale tracking. The brief notes that it is, and I quote, difficult to hide below the clouds today, which makes environmental non-compliance just far riskier.
And that transparency is what makes the investment worthwhile. But here's the challenge. All those satellites, they generate raw data. So the OEMC project's core objective is to bridge the gap between those raw space assets and the people who actually need to use it, the end users. They are laser focused on making data fair, findable, accessible, interoperable, and reusable.
And here's where it gets really interesting. They're focusing on moving beyond just raw data. We need to distinguish between different levels of data readiness. So analysis ready, data AR, that's what scientists use. But what about policymakers?
Right, and that's where we get into decision-ready data, or DRD. That's data that's been specifically processed and packaged for policymakers and for businesses. But the most crucial evolution for accountability is something called forensic-ready data, or FRD.
Forensic-ready data? That sounds like something you'd bring to court.
Exactly. FRD is data specifically structured to hold up in court or during a policy audit. It means the information isn't just a satellite image. It's a verified, time-stamped, and spatially precise record. It proves that a specific parcel of land was degraded or a specific riverbank was polluted on a specific day. This level of verification is absolutely essential because the original data producers, ESA or NASA, they don't typically have the capacity or the mandate to prepare data in that legally robust format. And that's why OEMC's work is so vital. All right. So the OEMC project, which runs from 2022 to 2026, it's a consortium of 23 organizations, and it's based on three foundational premises that are necessary for successfully increasing the use of this data across Europe.
Okay, so what are those three pillars of success?
First, information has to be distributed as that decision-ready data we just talked about. Second, climate action requires citizens to be fully aware of the financial co-benefits of ecosystem services. I mean, showing people why protecting a wetland actually saves them money on flood insurance. And third, users must be central to co-designing the monitoring system itself. It can't just be a top-down approach.
Those are excellent premises, and they're backed up by concrete things they are already delivering. To boost data availability for users on Europe's main platform, the Copernicus Data Space Ecosystem, or CDSE, they added the entire historic Landsat archive from 1997 to 2024.
That is massive. We're talking about 150 terabytes of new, highly usable, analysis-ready cloud-optimized data, or ARCO, integrated directly into the European platform. That extended historical window is just critical for identifying long-term trends in land use and climate impact.
They also produced 50 million open field boundaries across the entire EU to support pan-EU crop classification. That's essential for accurate agriculture monitoring and for implementing policy like the Common Agricultural Policy.
And you see the power of this synthesis in projects like the World Reforestation Monitor. This initiative uses high-resolution, 20-meter maps of variables like leaf area index, or FVC, fractional vegetation cover. This data lets environmental managers track land and ecosystem restoration progress year by year, objectively validating whether the ground conditions are actually improving, not just relying on self-reported data. The conceptual foundation for how they organize all this development and data sharing is one of the most intriguing details in the report. They explicitly state they are inspired by Fediverse-type infrastructures. It's such a powerful analogy, right? Drawing from platforms like Mastodon. The goal is to move away from these monolithic, centrally controlled data systems. They want to organize open development into efficient, decentralized, open collaborative systems, a data Fediverse. This allows different groups and regions to process data locally using computational notebooks, which maximizes efficiency through distributed effort and avoids bottlenecks.
I love that comparison to Mastodon. So we are essentially looking for the decentralized, community-driven, open-source approach to organizing the planet's data, rather than a single proprietary, Facebook-style approach. That makes perfect sense for resilient environmental governance. That focus on decentralized efficiency brings us right into the biggest technical problem facing the entire Earth observation sector. We are structurally inefficient. We're wasting petabytes of data and significant money in the cloud.
This is a major paradox. We have this cutting-edge space technology, but its implementation is hobbled by these massive administrative and technical inefficiencies. Cloud data centers, like Google Earth Engine, hold over 20 petabytes of EO data, but countless organizations unknowingly run the exact same redundant data pre-processing steps over and over and over again.
And this isn't just about wasted storage space, right? This leads to an unnecessary burden on computing resources and, critically, a huge preventable carbon footprint from all these redundant processing cycles.
They cite a specific, almost unbelievable paper titled Wasting Petabytes, which quantified this structural waste. It showed that the inherited structure of the UTM-MGRS grid overlap alone inflates the yearly Sentinel-2 data volume from 3 petabytes to 4 petabytes.
Wait, hold on. A basic grid overlap inflates the data volume by a full third.
A full third.
That is just pure waste. I mean, are we really still mapping the globe using methods that are structurally similar to 19th century maps? That sounds less like high-tech space science and more like massive administrative inefficiency.
It is a legacy issue, yeah. It's tied to how different mapping zones meet. But addressing it is crucial. The solution involves moving to highly optimized data formats. OEMC is testing cloud-optimized formats, specifically cloud-optimized GeoTIFFs, and newer, even more efficient formats like GeoZar and GeoParquet.
Okay, so what's the practical difference between a standard data format and a cloud-optimized one?
Cloud-optimized formats are structured so you don't have to download the entire file to read just a tiny section of data. They're built for distributed infrastructure. They let users request only the necessary bytes from remote storage, which dramatically reduces bandwidth, processing time, and cost. This is the only way to scale sustainably.
And the report emphasizes the Copernicus Data Space Ecosystem, the CDSE, as the priority for these efforts.
Exactly. The CDSE is Europe's fully operational platform. It hosts nearly 100 petabytes of data. This is where EU-funded projects have to concentrate to maximize the return on investment for European citizens. They also mention exploring discrete global grid systems, or DGGS.
DGGS. What's the advantage of that over the current grid system?
DGGS is a fundamental rethink of how we map the globe. It uses tessellations, usually uniform hexagons, instead of the traditional squared pixels, which inevitably cause those overlaps and distortions, especially near the poles. DGGS tackles space optimization head-on, providing more correct spatial representations with less distortion, which is essential for global scale accuracy and for reducing that wasted petabyte volume.
So what does this all mean? I mean, if we look at the sheer technical challenge, the GeoAI revolution isn't just optional. It's the inevitable answer to this explosive volume of data we're facing. We have over 11,170 EO satellites in orbit now, and more than half of those were launched since 2019. They're generating hundreds of terabytes daily. AI is non-negotiable for achieving actionable intelligence from that torrent.
That exponential growth just necessitates automation. AI is already crucial for automated tasks like instantly classifying millions of fields for crop types or speeding up disaster response by doing damage assessment in hours, not days, or tracking deforestation globally in near real time. We also see deep learning models like Google Earth embeddings compressing data by hundreds of times, which makes it accessible to users with minimal computing power.
And the future concept of onboard AI or edge AI, it's truly mind-blowing. Instead of sending all that raw data back down to Earth, which saturates downlink capacity, the AI moves to the satellite itself.
That's the breakthrough. The AI can autonomously filter irrelevant data, for example, automatically detecting and just discarding cloud-obscured imagery, and prioritize only the valuable cloud-free observations. This maximizes efficiency and minimizes the use of scarce and expensive downlink bandwidth. The satellite makes a smart decision in orbit, only sending back, the 2% of the image that is actually useful.
But this rapid advance, it raises critical and immediate questions about governance, starting with digital sovereignty. We're building the most sophisticated environmental monitoring system in history, but who owns the cloud infrastructure that runs it?
That is the core vulnerability identified in the report. A small number of U.S. companies, AWS, Microsoft, Azure, Google, they dominate 70 to 80% of the European cloud services market. They offer cutting-edge technology, yes, but this level of dependence weakens the EU's sovereignty over its own crucial environmental and security data. The report emphasizes that reliance on non-European partners for processing such sensitive data presents a strategic geopolitical risk.
And beyond sovereignty, there's the ethical footprint of AI itself, which the report addresses very powerfully. AI requires massive computational resources that leads to huge energy consumption, water use for cooling, and a rising mountain of e-waste.
The authors introduced the concept of the Earth alignment of AI. This is an ethical mandate that dictates that the development and deployment of GeoAI must prioritize planetary stability and resilience over the traditional metrics of shareholder profit or rapid growth. It's essentially saying, the tool we build to save the planet must not itself destroy the environment through its unsustainable footprint. And if we connect this technical capacity and these ethical concerns to the bigger picture, we arrive at the highest level policy implication. The vision that open Earth observation monitoring might soon become the objective basis of a new environmental accounting system across the EU.
That is a radical shift. It implies that EO data is moving beyond simply monitoring and into the realm of economic valuation and taxation.
Precisely. Right now, our financial and tax systems are outdated because they fail to objectively recognize the cost of losing essential ecosystem services due to human activities. Think about carbon capture by forests or flood control by wetlands. A transparent, tax-like system, the brief suggests, will be needed to compensate for costs like GHG emissions and land degradation.
And that compensation system has to be based on objective, non-negotiable data. Satellite images and EO data become the immutable foundation of this new data-driven governance.
Absolutely. The ultimate potential of combining these fused technologies is what they call Earth intelligence. This is the natural marriage of EO and GeoAI technologies, aiming not just to map the Earth, but to generate fully actionable insights about the planet's incredibly interconnected physical, biological, and human systems.
It sounds like we're moving towards something that could truly help us navigate the future.
The authors envision a hypothetical model where artificial general intelligence, or AGI, combined with supercomputers, could simulate future scenarios, blending human behavior, biological feedback loops, and socioeconomic systems to help decision-makers find the optimal, most sustainable path forward. They even provocatively suggest that AI could be used to moderate the compliance and negotiation within future Paris climate-type agreements, ensuring that targets are transparent and universally measurable.
And for all this high-tech governance to truly be democratic and robust, they stress the crucial role of the public. They argue that citizen science initiatives must play a more prominent role, leveraging AI to enhance data quality and engagement, perhaps through gamification or token systems, to motivate young people to contribute verified ground truth data. So, let's summarize the key takeaways for you as we close this deep dive. First, Open Earth observation is not merely a scientific tool, it is a mandatory, low-cost safety mechanism whose societal benefits massively outweigh the initial investment.
Second, the immediate frontier is efficiency. The EO sector has to stop wasting petabytes of data and shift decisively to producing analysis-ready, decision-ready, and crucially, forensic-ready data, the formats that truly power policy and accountability.
And finally, the GeoAI revolution is here to manage the explosion of data, but its deployment must be paired with careful policy ensuring Europe maintains digital sovereignty and mandates that AI development ethically aligns with planetary stability first and shareholder profit second.
This entire deep dive, it shows that we have already solved the technical challenge. We have the capability, through Copernicus Sentinel, to monitor our planet down to the level of an individual olive tree or a single act of illegal deforestation with weekly, transparent precision. Our technology has made it difficult for land use change to hide from the public eye.
So we've solved the technical challenge, we can see everything. The question is, are we politically willing to look?
Which raises an important question for you to consider. The source notes that while Copernicus satellites have the technical capability to monitor forests with high resolution, political resistance, primarily from powerful member states, led to the recent rejection or watering down of the proposed EU forest monitoring law. If OpenEO data provides such objective, transparent, and public evidence about the state of the environment, why do political systems actively resist creating laws based on that same objective evidence? What is the final non-technical hurdle for the green transition?